Hello everyone. So in this talk we are gonna explore about hybrid search. Within we will combine neural, sparse and dense vectors. I am Seema Saharan. I'm currently working as an SRE at Autodesk. I'm also a CNCF ambassador and also a AWS community builder and organizer for various user groups across India.
And again, yeah, this is Aditya Soni. I'm currently working as DevOps Engineer 2 at Forrester. Before this, I was working at Red Hat. And yeah, I'm also one of the CNCF ambassador, speaker, mentor. So today's topic, we're gonna explore about like how the roadmap of the hybrid approaches goes. Okay, so you guys already have learned a lot since today, like about the search topics. Maybe you might have gone through already like how the traditional search approaches go, or maybe like the vector or sparse or dense. I'm not sure what you have gone through, but in this talk, we're gonna go through with the very basic, and then we're gonna discuss about the vector search, and then we'll move to with the neural search. Okay, so the first thing we're going to discuss about the traditional search methods. What are the methods that's actually available to search the things? And after that, maybe we can move forward with the understanding of the dense search. So how that actually happens, and maybe like if you're trying for the very first time, then how you can build that. Then we can understand like how the neural sparse actually differs, and then how it actually basically you can build by your own. Then we're going to discuss about like the hybrid approaches. So currently we are trying to build something around the dense and the neural sparse. So that's what we're going to do, and you would be surprised like how the results will be best of the both worlds will be different. And then we will be discussing about like how OpenSearch supports hybrid. So like there are lots of methods and like a lot of tools that supports hybrid searches, but with OpenSearch it have some extension, and maybe you will get some benefits upon that. Then yeah, we will be having a quick demo where we will be discussing around like how hybrid search actually can be implemented, and you can utilize that in day-to-day activities. And then yeah, at last we will be having some key takeaways and Q&A. So starting with the traditional search approaches. So you guys have already must have gone through with a lot of websites. Maybe if I take you the most smallest one, that's maybe the Amazon.com or maybe the Blinkit or anywhere. Whenever you search something, you just get popped up with the same stuff. Let's say I'm going on a track. I'm just searching there. Maybe I want basically a track bag. So I'm getting all of the basically searches related to track bag at the same time. But if you guys notice there, at the same time with the track bag, it's giving you suggestions. You might need track pant, you might need like track gloves, you might need track shoes, something like that. So how that actually happens? So with help of traditional search, actually that's not happening, because what traditional search actually do is it's give you direct, I would say, response according to what you are searching. So if you are searching only track bag, it will show you only track bags, something like that. So we do have different methods to do that. The first one is like the Boolean search. So Boolean search is I would say the most simplest one. That's actually do only with the binary matching. Okay, so there is no ranking, no nuance. Okay, so whatever thing you are writing, whatever basically query you are searching, you will get the results according to that. Okay, so that's one, the Boolean search. If we go more than that, like we will have the TF-IDF. So that is something like it actually ranks the document according to the basically how the frequency we are getting from the same basically whole document, you can say, or maybe the whole HTML page. Okay, so the Boolean search, you can take an example of maybe you are on a web page and you're doing Control F on the Chrome, and then you're searching something. So that's how the Boolean search actually works. But if you go with the TF-IDF, so that's I would say like the advanced version of the Boolean, and in this like the document will be ranked. Okay, so how much query or how much things you are searching, according to that it actually ranks how much occurrence that particular word is coming. Okay, so accordingly it will be just giving the ranking, and the most ranked search will be at the top, will be shown to you. Then we will be having BM25. So it's like best match of 25. So the full name is this. So it's improved the TF-IDF, and it consider basically term frequency, at the same time saturation and document length. Okay. it's actually good when you are exactly searching for some keywords from a particular thing. So that's when like BM25 can work well. So if you see at this side, so we do have one user query that we are just putting here. And when user query is given, so we are using here the inverted index lookup. So that's where like the major, I would say, the magic comes in picture. So and then the BM25 rank the result. So this is a particular example for the BM25, and that's how actually it gives you the results. If we go ahead, then if you think of a classic search pipeline that you must have been using or might be used before. So let's say if a user just search for a query that's bank, but inverted index or BM25, or maybe if I talk about TF-IDF, so these particular methods or models will give you only the results like river bank, financial bank. But if you see, if as a customer, as a consumer, if you are searching for a bank to withdraw some money or something, what you will do with the searches, river bank or like other stuff. Okay, so actually it's not checking on the meaning. Okay, it's only giving with the keyword search. If you search for the bank, wherever it will be able to find the bank, it will share you the same response. But it's not able to understand the meaning, and that's where the traditional search actually fails. So if you see, like we are able to retrieve all the keyword matches, but at the same time, they are having different meanings. Okay, and that's where the classic search pipeline do fails. So that's how like we came to limitations of the traditional search. So if you see about what are the limitations that we were getting from the traditional search, is like the first one is like no semantic understanding. So it actually can't distinguish between word, meaning, or context. So whatever you're searching, that's a different thing. What's the meaning? That's a different thing. And the context that you're trying to do the stuff, that's a different thing. So it's actually not able to correlate with all of them. The next one is like it fails with synonyms and paraphrases. So let's say you search for the car and you wanted to have something similar to automobile. Okay, in keyword matching, but it won't be able to do that. In car, it will be only searching for the car as a keyword, but if you related to car anything, it won't be able to get the meanings. Okay, then we have no personalization, because same results for all users regardless of context. So let's say sometimes if you have seen like in India, like if there are different states, if you go with the north side, there are different festival that's going on the same dates, and in the Bangalore or somewhere, like there's a different festival is going. But if you have seen like the products like Zepto or Blinkit or something like that, they do differ their queries from the user basis, and they show the whole stuff according to that. So with the help of traditional search, you can't actually do that. Okay, so it's like you will be showing the all same results to the same geographical, or I would say the whole the India itself. But what if the personalization should be there? Then we have the relevance gaps. So there are some strict keyword matching, like if in the same pipeline, if you see here, so you can't actually change the stuff by your own. You can't actually add some models or something like that. Okay, so there are a lot of gap that's coming in. And then we have computational cost. So it's actually, when it comes to large data set, it actually takes a lot of time to search specific keywords from the whole data set, and then it gives you the queries. When you're maybe searching in a smaller doc or maybe in a smaller page, then it's good. But if there is a lot of data that you're having saved and it's a large product, then it will be more expensive and a large data set. Okay, so that's how we were having some challenges, and we came to dense vectors. So yeah, what are dense vectors? So dense vectors are the embeddings, and it's basically compact continuous array of numbers generated by neural network. So suppose like you are searching something bank, and you're not able to find the whole keyword as a bank, but at the same time what you're able to get is the vectors of the neural embedding of the same. Okay, so and according to that only it will check like what are the nearby same results that you can get. Okay, so for doing so, it's uses some algo in between that. So if you see here, like dense vector, most values are non-zeros and encoded semantic relationship in lower dimension space. Okay, so it actually uses 768 dimensions for BERT. So again, it's a particular, I would say, technical term, or I would say internal thing that it actually uses to convert the vectors to embed. Okay, these vectors enable semantic search, basically it actually find the result based on the meaning, not just on keyword. So the previously in traditional search, what you were doing is like whatever things you just put, you will be getting the result accordingly. But it actually means what you want to share, or what you want, what actually your context is when you're searching something. Okay, so let's discuss more about this, like how vector search actually work. When you maybe just typing something, you're just trying to fetch any details, so how it goes. So as a user, let's say if you put input sentence, that can be anything. After that, the embedding model, maybe word or word to see, etc. Those will be there to embed the whole text that you have put. I'll show you later like how that actually looks like when you embed a particular basically text or particular keywords. Okay, so that particular sentence will be embedded. Once that is done, the dense vector captures the sentence meaning. Okay, so once we are having the embedding done, then it will look for the data set. It will go in your data set and it will check like with the same similar meaning, what else I'm able to get. And accordingly, it will go and it will check like the approximate nearest number. So that's what I was saying before, like it's use algo, so it's ANN only. So it will check like the which is the nearest neighbor for me to check. Let's say I search for a t-shirt, and the t-shirt's having a value called 1.83. That's the vector embedding I'm saying. So now again with the t-shirt, if I'm searching shirt, so maybe shirt can have an embedding around 1.75 or maybe 82 or something like that. So it will be nearby. So accordingly, you will be getting the results when you are searching it. And semantically similar results you will be getting after all of the the process or the flow, I would say. So you can take this example also in picture. It's showing some of the types of. So if you see here, it's a type of rocks. Okay, the user put the query that is a thresh rock, and it was not able to find the exact query, maybe thresh rock. So, and if, let's say even if it's able to find the thresh rock, so let's say if it's able to find the thresh rock, so it will check the nearby. So as we discussed before, it actually look for the approximate nearest number. So that's what it's doing. So once it finds the query and exact word, that's a thresh rock, it would also show the nearby numbers. So when the search result or output will be coming, it will be showing you anthrax or metallica or slayer. So these are some rocks type actually. So and that's how it will show you all of them. So that's how actually like the particular text is converted to embedding, and once you are searching it, so you are able to get all of those embeds in particular nearby neighbors. Okay, again like how dense vector actually works. So maybe let's say a user put a query like blue shirt, t-shirt, as I told before, and embedding model will convert this to the dense vector, and that embedding can be 0.012 or minus 0.98 or whatever it is. Okay, now the ANN search finds the product description like sapphire tea, even if the exact word don't match. Let me elaborate you more. So let's say I just search for a particular keyword, that's the blue t-shirt, that we're having embedding starting from 0.72, and then there's a minus 0.45 you can see on the screen. If you see, I can see the nearby embedding also from this. So maybe not from blue t-shirt, then you can see the navy shirt. So it's having the similar the embeddings here, and at the same time it will create the ranking. So which one should be at the top and which one should be at the least, and that's how actually it ranks the results according to what you want to have. So even if the same thing if you do from the traditional search, so you would be only getting blue t-shirt, and after that you might have got blue bucket or blue basket, something like that. So it will only search regarding the blue, but now it knows you are looking for a t-shirt. So it's sharing you only related to blue things, and that should be variable. At the same time, it should be a shirt, t-shirt, or maybe the upper wear only. So if you see as your top, colbitter blouse, or maybe sapphire tee, something like that. Okay, so how the embedding actually works. So whenever you put some objects in the embedding model, it actually goes through with a particular process. So let's say I have put it here 3 objects, object 1, 2, 3, and that particular embedding model converting those to vectors. Okay, so now here the embedding model trying to convert one by one to the vector. So that's how like with the help of embedding model, and once you put the query, it will just convert them to the vectors, and that's how the vector search actually work. But how the dense vector actually differentiate from traditional search, and why actually over that we are using dense vector. So if you look more deeply inside this, so you will see like we do have some features here, and at the same time we are comparing them with the traditional, I guess BM25 and TF-IDF, and with the neural or like the dense one. So if you see here the representation, so here we have all non-zero, okay, in the dense vector, but at the same time as in the traditional search you will always get and embed all the zeros. But when you have all the zeros, then you can't be able to do the differentiation, or maybe you can't be able to do the ranking according to the whatever search you are having. Then the capture meaning. Obviously, the traditional search can't check the meaning. It will just fetch the particular keyword and it will give you the result accordingly. Then we have synonym handling. So in this, like dense vector is good, but again the traditional won't work. And context awareness, again like the traditional can't do this. So dense vector actually helps you to understand what context, in what meaning you are trying to search, and what's your query that you are looking for. Okay. Then we have precision on rate terms. So on the precision rate terms, sometimes it misses in the dense vector, but in the traditional it would be always correct. Why? Because if you're searching for blue, what you have to do is it will go and in the same document to search for blue. If it's able to find, it will give you results, else it will say like it's not able to find, or maybe it will give you false result. So there's a more chances like you will be able to get like false results instead of the correct ones. Then we have interpretability. So it's like in the dense we are having that low, but in the again the traditional we are having that high, because each term you can visible and you can just check it one by one. And then when it comes to latency or resources, so again in dense it's higher, because we are using here vector or ANN search, and again in the BM25 it's lower. So that's all about, I guess, the dense and traditional. And if you look more around like the particular query, so again example, so let's say user put a query a car. So if you see here the BM25 or the basically bird, so in this BM25 actually share you only one result, that is a car, and automobile it gives a zero ranking, because for this it's only looking for the keywords. So it able to find only car for only once time, so it will give you a result of car but not automobile. At the same time, if we are looking for car from a dense vector, then it will share you the automobile thing also, because it's the context is matching. Somewhere around you are trying to search that. Okay, so BM25 only matches the car documents, but dense finds automobile, vehicle, etc. Because it will look forward to the nearby like the basically embeds, and it will just show you the results. Okay, but again, like if you are using dense, so it's not the end of the world. It's not like for each and every use case, whatever you have, the dense would fit in. It's not like that, because dense also have some of the, like I would say, some drawbacks or pain points that you have to take care of, and that's why like the only using alone the approach is not always a good one. So that's why we are using the hybrid one here. So let's go with the why dense is not always better. Because the first thing is latency. When you are using the vector search with the ANN, the computationally intense, and especially at the scale, so it takes a lot of time to go through the whole process that actually we gone through here. So it takes a lot of time when you have a lot of data set to create embed for each and every search you are doing, or maybe the whole data set, okay, and searching from them. So the latency again is the issue with the dense. And then if you see about the hallucinations, so yeah, dense models may return semantically similar but factually incorrect results. So even though if you see this particular diagram, it's to have some of the results that's actually not matching the particular user's query. So he wanted to have blue t-shirt, but he's getting some other things that he is not looking for. Okay, so that's how actually there can be hallucinations that can create some issues when you are going with this. Then we have misses rare exact terms. So while a user just want to have the, because as we say, like it's not always better to have upgraded things. If a user just want to have the exact terms, why we want to have the embedding there? Okay, so that's why like it actually sometimes misses the rare or exact terms for the particular I would say use case or something. And then we are having the interpretability. So it's like how to explain why a result was returned. Okay, so it's basically a black box nature, because once a result came in, you can't actually explain why in the dense vector it was nearby to that particular search that you put. Okay, so when you are getting the hallucinations or the wrong results, it's a bit tricky to actually troubleshoot that. And if you talk about some use case, so let's say that there's an e-commerce website, user searches for a specific product, code or rare brand, then search may miss exact matches. Okay, because if a user is trying to search something, but if the same thing is not available on the same website, then it will show something that is user is not requiring, and then the experience will be not good for them, right? And let's say if there's a legal docs, and so when it comes to legal docs, so it's more like they want exact precise things. Okay, it's not like you are sharing in legal documentation, or when there's something like that works, so you can't share anything. But in case of dense, the hallucination can be there, and at the same time it can give you the wrong results. Okay, now let's come to because there's again some drawbacks in the dense that we have already discussed. But how about the neural sparse search? Okay, so neural sparse search is a method where text is encoded into a sparse vector. Okay, so only few important tokens are assigned weights, making it easy to spot which word matter most. So instead of here we are creating embedding, we are just giving some weights to the particular searches, or I would say particular query that user have got. Okay, and accordingly we are just searching on them. At the same time, neural sparse do uses some like the internal ML models, and on behalf of that it gives you the best search results what it's having. So it highlights the key terms instead of hiding meaning in dense numbers. Okay, so it basically give you the meaning also. At the same time it gives you the key terms like what you are trying to search and what's the meaning of that. So it's like it's solving some of the problems that you are facing in the dense. Okay, it assigns a clear importance to each selected token based on relevance. So it as we discussed before, like it gives some weights to particular search that you have done. So accordingly to that particular weights, it's tried to give some tokens to them, and whoever search is having the most tokens, that will be showed you at the top in the ranking. Let's understand like how neural search vectors work. So neural sparse vectors basically. So when you have an input text that you have put it in the same pipeline, so then neural model like SPLAD, or maybe you can use other models from OpenAI, or maybe Hugging Face, or maybe Bedrock ones. So you can use any models like that, and you can just try to with the input text, you can just try to search for the token weight, or maybe you can try to search for the nearby, basically the like the whole keywords for the same. So once they got the higher weight from the whole data set, it will be at the top. Okay, so according to the model, it will just give you the token weight, and according to token weight, the query or docs will be converted to the sparse vectors for the user. Again, we are whatever you were using in a traditional, if you see before, like in BM25, you're using the same term, inverted index lookup. So we are including that here in the same flow, because in the dense vectors we were not able to, we were having some hallucinations and exact terms actually missing. So that's what the step actually we are including here, and once that is done, the fast search retrieval will be there. Now maybe let's understand this with again an example. The first thing is like the user maybe putting is like affordable running shoes. Okay, now the neural sparse encoder output will be like this. So for each and every term, whatever you are just giving, it will just create some again the vectors for the same. So for the affordable, it gives a 2.1 and 3.4, something like that. But one thing, if you notice here, like it's not giving non-zero weights here. Okay, because in the dense also, if you see, like we were getting around minus 0.9, 0.7, something like that. But in this, it will try to not give most non-zero like the weights to the particular searches that you're doing, and that's what the neural sparse actually do. Because only a few tokens have the non-zero weights, the model may expand the query with related terms, like maybe user searches for affordable running shoes. But now, as you are embedding another particular maybe Hugging Face or OpenAI model, so they will convert or they will check the synonyms for the affordable. So for the affordable, the another synonym is cheap. So it will look for the cheap sneakers, okay, and accordingly you will get the correct output, or maybe when users are searching, they will get the correct results. Again, what you're using the neural sparse, but that is also not always the better, because it's do also have some drawbacks, and that we're going to discuss. So it misses the deep semantics. Okay, so maybe when a term is having the deep meaning, or maybe let's say a particular person is typing something, but it's not able to check those meanings, so on the time it fails. Okay, it won't able to fully capture the data, and it will give the weights to the wrong terms that maybe inside the data set is available. Then another we have is rare term handling. So neural sparse models are strong at handling rare or domain specific terms, because if you are searching something related to a particular domain that it already knows, then it's good. But if it's not able to knows, then it might give you again the weights will go to the wrong data set, and or might be it won't show you anything, something like that. And then latency and scalability. So again, when you have largest data sets, so again this will be another issue. But if you are integrating or trying to integrate maybe the dense, or I would say dense vectors and the neural sparse at the same time, you might be able to reduce some latency, because then you are trying to having the inverted index at the same time you are having the embeddings. So on that time, like the search power will be increased, and you will be able to get the result better. So if you see here, like again the example, so for the e-commerce, if you are having the neural sparse excels at matching the product codes, okay, so it will just check better the particular product codes, brand or real terms, but may miss subtle user intent on context. So whatever user is trying to have the context, so it might miss that. Okay, so that's where the neural sparse again not able to meet the criteria. So now what? So what's the main conclusion or main thing that we should focus on? So yep, that is hybrid search. So this is something like you can have integration of the neural sparse or maybe dense vectors. With the help of that, you will get the output that is the best of the both worlds. So when we say best of the both worlds, so it's like you are having some of the things from the traditional search, some of the things from the vector embeddings, some of the things from the context side from the neural, and at the same time, while you integrate both of the like the approaches, and if you give the output to the user, so it will be like a best one. So in hybrid search, like it's nothing, just you are basically combining two of the search method, and you are giving some precise and context aware output to the users. Okay, so it processes the query with methods, then merges and re-rank the results. Okay, so whatever query you are putting, so it will just merge the results from the both. Let's say from the vector you are getting a result, maybe that's the vectors of that particular output, and then it will look forward to the nearest neighbor. Whatever nearest neighbor you have got, it will take the output from the vector. At the same time, it will take the output from the neural ones, and once it have to show the output to the user, it will combine both of the output, and it will show you the most precise outputs, something like that. So at the same time, you can maybe not misses on the hallucinations, and it's good for you to maybe if you want exact terms, at the same time context also. And it maximizes exact matches and deep semantic understanding together. Yeah, that's what we actually discussed. Okay. What are the benefits of the hybrid search beyond like maybe the dense or the neural? So again, as we discussed, like it gives you the precision and context. So with the dense vector, you will be having the embeds, so it will just go and check for the nearest neighbors. You will get that output, and accordingly you will have the another output from the neural sparse. So once both of the output will be combined, you will be getting best output from the both of them. Then we will have the improvement relevance. So now you are not able to, you're not actually searching from directly whole document and then output given to you. It actually correlate. So let's say if you're trying to search something, and it actually know the meaning of the things that you're trying to do, or maybe you're trying to go. So as at the starting I discussed about, like maybe you're going on a track, you wanted a track bag. So at the same time, it will suggest you like, okay, so you're going on a track, you might need track pant, you might need track gloves, there might be, it's a winter, so cold will be much, so you can get this or that. So it will give you some suggestions. Okay, or maybe you can take it like that, maybe on Zepto if you are maybe searching for ice cream. So with ice cream, it will give you some snacks also and something like that. So that's how like it knows like what you're trying to search, and it plays with you with the help of AI. And then we are having the versatility. So it's like it handles the diverse data types, user intents, making it suitable for e-commerce, legal and support and more. So whatever data type you're trying to push, actually OpenSearch, or maybe I would say the AI thing, actually accept that, because they use this at the back end, the vector databases. So even though you're trying to push an image in, from an image you want to have like, okay, from this image just try to search like maybe you can the whole diagram, explain me the whole diagram, or maybe you're trying to push a video, you want explanation of whole video, you can do that, because it do accepts the all type of data types, and it's not like you can only push some text, something like that. And then you have some enhanced user experience. So user can search naturally with keyword, full questions, without keyword, just a keyword, something like that. But if user gives more precise output, so even though like if you all must have experienced this, if you have like search on ChatGPT or something, if you just search for a particular term, what is OpenSearch, it will give you the what is OpenSearch only. But if you will explain more in what context you are searching OpenSearch, let's say you are going for a talk at OpenSearchCon India, or maybe you are going as an attendee at OpenSearchCon India, if you will give the particular question more precisely, like I'm going for I'm going as a attendee and OpenSearchCon India, what things I should be knowing before going to the conference, something like that. So it will give you some precise output according to what you are trying to go, what's your goal. Okay, so the more good output you will, basically the input you will give, the output will be coming from the hybrid search. Again, the enhanced user experience. So with the full questions, like you will be getting the good experience from the hybrid search. Okay, so now let's discuss about like how hybrid search works. So let's say that there's a user that's putting some query. So the same query will go to the neural sparse and the dense vectorizer, and it will just push the token weights, and it will just take those weights or maybe that output within it, and at the same time dense vector will create some embedding. Once that is done, they will be basically they will be creating some Sparse fusion, and they will merge. So whichever is the best output from both, whichever having the best weight from the both, they will be merged, and that will be actually final ranked list for the user. So that's how actually it helps user to get the more accurate outputs. Okay, there's again a particular example that we have already gone through before with the maybe dense or neural. So if user is trying to put some affordable running shoes, so in neural sparse you are getting some embeddings like this, or maybe some weights like this. You can take around this one, and from the dense you are getting some weights like this. But when the retrieval will be coming, it will just like in this we are getting some cheap sneakers. In this dense index actually giving us the nearby output, maybe budget friendly trainer or something like that, because it knows like if you are running, if you are trying to fetch running shoes, so you might be going on a track, basically you are going to a gym, or you are basically trying to do some physical activity, so you might need a trainer. So it will give you accordingly output, and then the hybrid output will be more precise, so what actually the user is looking for according to the final ranking. But there are a lot of challenges in hybrid search when you implement it. It's not easy as it looks, okay? Because as we showed, like you can just have the neural sparse, you can have dense vector. So it's not like that easy, because when you will do it, you will feel like when you do the dense vector only, you will feel like, okay, this is a lot. So it's not like that, but OpenSearch made it easy for you. Okay, so there are a lot of challenges that actually you can solve with help of OpenSearch. So if you see like the scores normalization, so there's a score, whatever score you're getting, you have to normalize that, and that's where there's a hybrid search, you may face issues, because which score should be having the higher ranking, something like that. And then we have some index complexity, because managing two or more indices and synchronizing the data. If you see here, like maybe sometimes they are, both are giving the same results, but at the same time, once you're trying to merge them, you might be confused which particular output is perfect for the user and which one we should parse them. And that's when the index complexity will be there. Latency, obviously, like you are trying like the whole, you are basically merging the whole two methods. So latency will be there. But if you are like more on the side of OpenSearch, so you might reduce some part of them. Then parameter tuning. So finding the right balance between the sparse and dense contributors for your domain. So you create basically a domain, and that domain is nothing, just you can think like a cluster that you're using, and that particular cluster is having which one parameter should be going inside and fitting to you. It's actually hard to utilize. But how OpenSearch actually helps you when you are trying to build, or maybe trying to build the hybrid search implementation. So OpenSearch actually supports the hybrid queries. So either you are trying to use a dense or maybe neural, or maybe at the same time you are trying to have the BM25 or TF-IF. So whatever you're trying to do, it do support some hybrid queries. So it will allow you to run neural, sparse, dense vector search in parallel. Okay, so once you run the parallel query, so at the end you can merge both of them and you will get the combined result in a single pipeline, the same way we did. Then you have some score fusion tools. So it do provide some built-in normalization fusion strategies. So with help of that, you can basically search things more powerfully. Then we have some flexible indexing. So it will help you to basically store. So it doesn't matter what kind of index you are trying to store and what kind of pattern you are trying to build inside the OpenSearch. It will help you to basically build index also, index pattern also. And later on, let's say if you want to discover it or maybe create some dashboards, you can do that. When it comes to scalability, so again, OpenSearch is designed for that. So and enterprise gets, so with the help of hybrid database or maybe vector database support, so that's there. So yep, let's jump to quick demo. I'll invite Seema again.
Okay, I think the time is very less, so I'll quickly show you how you can achieve this. So basically here we have taken the pre-trained model that OpenSearch already provides, and we have used the config.url. Here you can see basically the JSON file, and from this you can run this and create your own ML model. You can also pre-train your own custom models as well. So when you so these are like basic cluster settings that you need to run. I have already run it, so I'll just quickly go through the commands. So next is how you will deploy this model into your OpenSearch. So I'm just using the same, like this is different, but I will use the same JSON and pass it here and use a post request and deploy it to our OpenSearch. And if you go over here in hamburger menu, you will get a machine learning section here in OpenSearch plugins. And here you can see all the models that I have already deployed. Some of them are not responding, but the status should be responding so that you can use those models. And model ID is really important here because we will be using that to process all the queries and search queries that we will do next. So first I have deployed neural sparse. Next, I have used a text embedding model and deployed it in the same cluster. And here we can pass our task ID. So when you run this, I'll quickly run this. So it will create a task ID that you will pass it here so that you can get the status if it's deployed or not. And if you run this, you will get like if it's created or not. And since I've already run this one, you can directly search this model here. I'm not just refreshing the page. From here, you will get the model ID. And next, you can create your ingest pipeline where you can pass on your data and you can run the basic queries. And it depends on your data as well, what kind of queries you are putting. You can convert this whole feature into a UI application as well. You can integrate that. And from here, you will see that I have passed like search product. So the data is publicly available that we have used for this demo. I can also share where we got that. And you see this, so we are using KNN vectors because that's what we usually use for neural sparse and all. And I am also passing some sample data for mobile phones like Apple, Samsung, and will be asking some queries like which of the phone is good for photography or anything that we want to search for. And this next step would be like hybrid search. So here I will pass the neural sparse and then the dense vector. And here we need to pass some vectors, and that's how we will get our output. And also, not just this one, I have some of the files as well. This. Okay, not this. Not able to find it. But if you have a demo data, you can generally ask like how many products like this model has. Like, let's suppose how many phone are available in your data center, in your inventory. You can ask like simple questions as well, and it depends on your use case. If it's an e-commerce, you can ask questions related to products and help improve the search. Quickly back to this. Okay, some of the key takeaways is hybrid search is usually what we have seen is hybrid search is also combined with the dense vector and semantic search. That's where you can start, and it doesn't mean that you always have to use hybrid search. In some of the cases you need to you will see that your data works well with neural sparse, or some of the cases your data works well with dense vector. So it's up to your data and how you have trained it and which search algorithm that you want to use. And so there are some benefits, and since it's in OpenSearch, you can use managed OpenSearch in AWS that can provide scalability, and it also has GenAI readiness. And since we all know that OpenSearch is mainly a vector database, that we can directly embed it to Bedrock as well. So in those cases as well, it's simple integration with Bedrock models, and we can utilize that search, and it will be much more simpler for you if you're just starting your journey with OpenSearch. And hybrid search isn't just an upgrade, it's a strategic stepping stone to AI-driven search experience. Thank you.
Okay, thank you, team. Any questions?
That was very informative. So thanks for
you.
that. I had a question regarding the dimensionality. So a neural sparse vector and a dense vector, both of them have different dimensionality. So when we are going for a hybrid search approach, how is the dimensionality determined, and what impact does it have on the overall search?
Okay, so you can do this in a two-step stage as well. First, you can apply dense search, and then you can on your data, after you do like dense search, after that you can also add neural sparse on that. So I think you won't face the dimension issue in that case if you apply two-stage process. Yeah.
And how is the search impacted with this change in dimensionality? Is it
I think we haven't explored that yet. Maybe we will. Yeah.
Thanks.
Okay, just wanted to reconfirm. So there will be two embeddings created at the indexing time and during the search time, right?
Yes.
Yeah.
When we have hybrid search
Yes,
implemented.
that's true.
And regarding the neural sparse, how does it handle domain-specific words? Like, is it just like English vocabulary, or can we fine-tune, or how?
Yeah. like we mentioned that we can use any of the model that is available publicly, like a Hugging Face or OpenAI, or you can also train on top of that your own data. You can train that, so it's customizable. Yes.
And is it supported in the managed cluster one? Because I saw a local host which you were doing.
I think it should
Yeah,
be.
it is, I guess. Not a big deal because this is the feature of OpenSearch, not related to that particular local host or managed, or maybe if you are trying to build your own on Kubernetes. Because before this today, I had a demo for observability at the starting, and that time I have built one of the custom search, or you can maybe include multi-model also.
Yeah.
That also works. Fine.
And what is the response time basically as compared to a multi search in lexical as compared to a sparse search?
No, basically in multi-model, it depends on you, like which particular type of model you are using, and accordingly.
I'm sorry, not the multimodal. I'm talking about the lexical, dense, and sparse.
Okay, so you're just trying to compare all of them?
Yeah, traditional.
Okay, so like if you're trying to go with the latency, or maybe like which will be the best for you for the most of use cases, so I would say like go with the dense vectors usually, because that is like it will give you some nearest result, and most of time it works for users easily.
Okay.
Yeah.
Any last question? Team? Okay, then thanks a lot.
Yep, thank you so much.
Good
Thank you so much,
session.
everyone.